So I will start to share with you some insight about the subject. But before that, this morning, during the presentation, highlighted by Her Excellency Minister Leila Ben Ahli, and during the ministerial plenary, countries and people worldwide cannot wait because the impact of the climate change is here, impacting our life. In every country, in every continent, we are impacting by floods, by droughts, less and less rain. Here in Morocco, we know that because it's the 7th year of droughts, and we have less and less water, and the level of our dams is very low, pushing the country, the governments, to find solutions to invest in desalination water, for example. And this is the same in many countries. So, what to do? We need to accelerate the energy transition and to decarbonize the industry. I don't know if we... Yeah. All the countries, about 196 countries on 200, so more than 98% of the countries have signed the Paris Agreement. This Paris Agreement contract is pushing countries to have action plan to maintain the increase of the temperature within 1.5 degrees. So if we look at the objective to achieve this target, based on countries' own planning and based on the scenario of 1.5 degrees, we see that the hydro, the solar, PV, wind, onshore and offshore, will generate more than 70% of the global power generation. Bioenergy will become an important source for power generation. In both scenarios, gas will decrease but will stay a source of power generation. In both scenarios, nuclear will stay a source of power generation. If we look at the energy mix in these two scenarios, projection for energy mix by 2030 and 2050 raise that part of the fossil fuel means energy from oil, gas, and coal will decrease from 63 to 12%. Renewable share in electricity will increase from 28 to 91%. Green hydrogen and e-fuels will increase to 14%. Modern use of biomass will increase to 16%. If we look now to the hydrogen in an international context and in these scenarios, hydrogen and its derivative fuels, such as methanol and ammonia, will together account for 14% of the final energy consumption by 2050 in the 1.5 degree scenario. Supply growth will be exponential to target 60 exact joule. Electrolyzer capacity need to produce H2 will also increase exponentially to more than 5,700 gigawatts. And if we look at one of the applications of hydrogen, which is ammonia, we will create more than 500 million ton new ammonia capacities using renewables inputs, means electricity, PV, wind, or biomass. And 70 million tons existing ammonia capacity shut down or will be converted from fossil to renewable inputs. So in this context, we will address some key questions here, and how we can accelerate energy transition to more renewables to reduce greenhouse gas emissions. So, and how the markets for renewables and the demand from industry is and will be. What and how is the technological and industrial maturity? We know that competitiveness is key for industry, but new technology as green H2 or green ammonia need time and investments to become competitive. How to manage this dilemma? One of critical impact of climate change is less rain and less water in dams for people, for agriculture, pushing countries, as I said, like Morocco, to invest in desalination. How renewable can support to decrease cost of desalinated water? How this situation of climate change and energy transition can be an opportunity to create new businesses and more jobs for young people. And how research and innovation can enhance supply chain logistics for global green H2 integration. And last question we will address today is how also digital and AI can support the green industrial growth. So let me now ask Si Khalid to intervene in these first questions and to share with you some insights. Thank you.
Okay, thank you, Mr. Chairman. Thank you for this introduction, and thank you for this clear view shown on the status of the ongoing markets. So before to move to this answer your question, I would like first to raise one big point. I hope it will work. Yes, I just asked ChatGPT to draw me a picture about our world, about what will be the future if our world, if we don't do anything about this climate change. So Mohamed showed already some scenarios to increase the temperature. It was the objective about 1.1 degrees Celsius. We are talking about 1.5. And if you do anything, maybe you'll move to 3 to 4 degrees Celsius. To give you the urgency of what we need to do, let's imagine as a man, as a woman, when you measure your temperature, when your health is okay. I think you are around 37 degrees Celsius. If you have 1 degree more, I think we start to have a fever. 2 degrees Celsius, 39 degrees Celsius mean we start, I think, we are not good. 40, it's urgent. Let's imagine the same for our planets. If you do anything, I think the Earth will have a fever, and we need to do something as soon as possible, and it becomes very urgent. This is why we need this carbon neutrality for our future. And we know how to do it. We know the factors when we have to play on. I think Mohamed already shown that, and I think all the experts already talk about it. We know the way we have to do it. We have to manage the demand. We have to work on the supply, and from the supply we are talking about renewables energies, which is one of the main driver. We can also extend this to low carbons energies, because there is not only renewables, but we have also nuclears and others low carbon energies to decrease our CO2 contents. We are talking about carbon captures, which is also could be a solution to decrease this amount of CO2. But at the same time, we need also to have all the infrastructures around what we are trying to do and what we're trying to develop. And at the end, as I see on the right side, I'm talking about regulatory, because it's a key. Without regulatory, we cannot go further on what we'd like to do. Achieving carbon neutrality becomes very urgent, need to accelerate what we have to do on this market. So, to do that, of course, we need a technology. Hydrogen is today one of the game changer to reduce the CO2 content. When I talk about green hydrogen, we have today a solution. But please take into account the fact that we are talking about green hydrogen, and we need to talk about also maturity of this technology. When we talk about the maturity, we need to take account two parameters. Most of the time, when, as a technologue, we are talking about TRL, technology readiness level, when people say that we are in TRL 9, that means the technology is mature. Yes, it's true. But we forgot something which is important, is how we can accelerate from this TRL 9, time to market. How we can move from technology maturity to industrial maturity. And here the way could be moving from one side to the other, and we need to accelerate on that, and we have to take into account the fact that the road to more mature technology in an industrial way has to be taken. So again, this maturity has to be also linked to the tests, because we cannot move from technology maturity to industrial maturity without any testing. Meaning that enhancing what is going with the hydrogen in terms of safety, in terms of viability through the testing is a key, and we have put all the efforts all together in order to accelerate by testing, by learning, by sharing knowledges about what is going with the hydrogen in order to become more mature in the industrial way.
Thank you, Khalid, for these insights on the subject. So we understand here from your presentation that we need to decarbonize industry, but the TRL is very important. The maturity, the technological maturity, industrial maturity was very important. But here to decarbonize industry, well, here the point is to make the link with renewables, and again, how renewables can support this, this acceleration of the decarbonization and the energy transition. So I give the floor to Sir Omar to give more information and insight about these points and about the question we explained and present you before. Thank you.
Thank you. So I think what I want to show here from the two maps, which is the wind and the solar map capacity in Morocco, and I want to emphasize my presentation on Morocco. You can see from both the huge potential. So there is huge potential of unlocking wind and solar capacity to green electron that will make Moroccan economy and Moroccan industry look completely differently in the different paradigm. But this requires some structural changes. First, we will need to unlock the capacity of the grids, because if we need to have more renewables on the grid, it's very important to have smart grid and grid that will allow for additional renewables in the network. And this is not only a problem of Morocco, in the world. The investment on the grid, due to the fact that green electron is now more affordable, more competitive, and also we can implement them on fast-track mode, make that the bottleneck is the grid. And the investment based on the International Energy Agency on the grid, it requires between 3 to 3.4 trillion of dollars required on investment on the grid in the next decade. It requires also a flexible capacity on the grid. So we will need more gas combined cycle, gas open cycle on the grid in order to integrate more renewables on the grid and make industry benefit from cheapest and decarbonized source of energy. In Morocco, the investment on the grid required in the next 3-4 years is between $5 to $6 billion, including the south-north grid or line that need to be developed in the next 4 to 5 years, which could be HVDC line that will unlock all the potential that we can see from this map in the south of Morocco and benefit the total economy, including the global development on green hydrogen, but not only green hydrogen, on cement, on all the carbon-intensive industry that can be decarbonized through this availability and affordability of green electron. Morocco has developed comprehensive roadmaps for green hydrogen through Moroccan offer, the water roadmap to make water available from green electron. So the green electron, we are talking here about power to X. So here the X is hydrogen, but also water. The needs of Morocco is between 1 billion to 1.5 billion cubical meters, and to produce the most competitive cubical meters of water, it should come from the green electron. So the water roadmap, the basis of this roadmap is green electron. We have also the global framework for the grid, for which there are investments that are planned in order to improve the integration of renewables on the grid, and favorable investment conditions and incentives that have been put in place in order to make sure that the green electron, again, will be affordable in all the country. Here I want to make a focus on the Moroccan green hydrogen offer. So we know that Morocco is on top decile countries in terms of capacity to produce hydrogen and derivative at one of the lowest costs. But this is require some important actions, mainly the enhance and building bridge between the academia, between the universities, and enhance the knowledge transfer in order to make sure that our green hydrogen production will benefit all the ecosystem in Morocco, being universities, being creation of jobs. And here we have statistics based on what have been mentioned by Irena, which is 30 million of jobs in the next decade will come from green economy. In Morocco, we can benefit for at least between 500,000 jobs only for the green hydrogen and all the derivative around green hydrogen, because we have the opportunity to use this green hydrogen to produce in the future the fuel of the future, which will be the e-methanol, in order to decarbonize the maritime fleet of the world. We are very well positioned in the world. We have 3,500 kilometers of coast, significant port that can serve all Europe, but not only Europe, internationally. And we can even not have to do I would say, the marketing to sell this green hydrogen derivative. It will be in our port. The only thing that we need is to, again, making sure that all the bottlenecks will be behind us with the availability of biogenic CO2 that are required, and also making sure that we create all the environment that will benefit and enable the investor to have a fast-track execution. And this is possible, and through the Moroccan roadmap, we can see that today we have the framework to do it. The other maybe element that will also important on the green hydrogen is not, we cannot take the green hydrogen as a source of energy. It's a vector of energy, and we need to think how we can export this energy in different forms, in the form of ammonia, in the form of e-methanol, and we need to have a comprehensive framework between planning between what we need in terms of green electron available for the grid and green electron needed for the green hydrogen project. And this planning is very important, and having the holistic view will help for sure to be one of the leaders in the future.
Thank you, Omar, for this interesting insight. So, what we understand from your presentation is that Morocco has a great potential in terms of renewable, and these renewables are key to be competitive, to produce green hydrogen, or it's the derivative of green hydrogen, because to produce 1 kilogram of green H2, the competitiveness, to be competitive to produce 1 kilogram, we need very low LCOE, and 70% of the competitiveness is coming from green energy. So now we are making the link how the potential in Morocco can be transformed into a competitive way to produce hydrogen and its derivative. So now I'm coming to you, say, Nakosh, what's your insight about these subjects, how to accelerate decarbonization, how this potential in Morocco can be transformed and can be used to accelerate the decarbonization of the country and to serve also the competitiveness in the country and more globally in Africa, for example. Thank you.
Thank you. So I will speak in French. I think it's more easy for me.
Okay.
Je pense que, comme l'a dit M. Omar, aujourd'hui le Maroc dispose d'un potentiel en énergie renouvelable exceptionnel. Et sous l'égide de Sa Majesté, on n'a pas attendu que l'énergie renouvelable soit bon marché pour développer le marché des énergies renouvelables, puisque les premières réalisations dataient d'avant 2008, et comme vous le savez, l'énergie renouvelable n'est devenue bon marché qu'après la crise financière de 2008, parce qu'avant le CAPEX, aussi bien pour le photovoltaïque que pour l'éolien, était totalement différent de ce qu'il est aujourd'hui. Donc c'est un fait qu'aujourd'hui notre pays dispose d'un potentiel en énergie renouvelable exceptionnel, et comme l'a dit M. Omar, peut-être qu'on fait partie de 3 ou 4 pays dans le monde qui ont un aussi fort potentiel. Pour le Maroc, c'est aussi un problème d'indépendance énergétique, parce que vous savez qu'on a du vent, on a du soleil, mais malheureusement jusqu'à aujourd'hui, on n'a pas ni pétrole ni gaz. Et donc, le fait de mobiliser l'énergie renouvelable pour satisfaire les besoins du pays, ça aussi, c'est un moyen d'assurer la souveraineté énergétique du pays, de réduire l'importation des énergies et de baisser la pression sur la balance des paiements en devises. Aujourd'hui, pour revenir au sujet de la session, c'est clair qu'aujourd'hui les industriels, l'industrie de manière générale, a besoin d'une énergie décarbonée et compétitive. Pour une raison très simple, c'est que, comme ça a été exposé tout à l'heure, les contraintes environnementales font qu'aujourd'hui, les produits, soit pour la consommation locale, soit pour l'export, doivent réduire leur empreinte carbone. Et on constate aujourd'hui sur le marché qu'il y a un changement de paradigme. Parce que les industriels, il y a quelques années, cherchaient l'énergie renouvelable compétitive. Aujourd'hui, ils cherchent une énergie renouvelable décarbonée. Ce qui change un peu la donne. Alors, c'est clair que les besoins du pays sont énormes. On a besoin avant l'hydrogène qui est un vecteur, on a besoin de développer l'électron. Parce qu'aujourd'hui, On a déjà démontré notre capacité à produire de l'électricité renouvelable pour satisfaire la demande aussi bien industrielle que pour les projets de dessalement. Vous savez que le Maroc, notre pays, a des besoins énormes en dessalement et qu'aujourd'hui, nous sommes en train de développer des projets de dessalement qui seront alimentés à 100% d'énergie renouvelable. Donc les besoins sont énormes. Le besoin, il est là. Comment accélérer? Ça dépend. Aujourd'hui, si c'est pour répondre à la demande nationale, je rejoins ce qu'a dit Sir Omar, il faut un peu développer le réseau de transport, parce qu'aujourd'hui, c'est une contrainte. Quoique, un réseau de transport ne peut pas être développé à l'infini, parce qu'il y a toujours une marge entre l'offre et la demande, sinon quelqu'un doit payer la facture. Donc il faut développer le réseau de transport. Il faut accélérer ce qui aujourd'hui est un blocage, si vous voulez, pour le développement des énergies renouvelables, puisque les centres de consommation sont plutôt vers le nord du pays et les sources renouvelables sont plutôt vers le sud du pays. Donc, et la topographie du réseau marocain, compte tenu de sa longitude, fait que c'est un réseau particulièrement difficile à... Il n'est pas maillé, donc il va falloir développer des autoroutes d'électricité. Ça, c'est clair. Après, une fois que ces contraintes sont levées, moi je pense qu'aujourd'hui, il faut développer des projets pour répondre à l'offre du pays. Si on considère le deuxième vecteur, qui est l'hydrogène, ben c'est clair qu'aujourd'hui, l'hydrogène, c'est l'énergie de demain, ce n'est pas celle d'aujourd'hui, puisqu'aujourd'hui, ça a été dit, les technologies ne sont pas encore tout à fait matures, la réglementation dans les pays importateurs n'est pas encore figée. Or, des projets comme ça, pour des investissements aussi importants, il ne faut pas oublier que pour produire 1 kg d'hydrogène, il faut 50 kWh renouvelables. C'est énorme. D'accord? Donc, il faut définir un cadre réglementaire qui soit incitatif, parce que il ne faut pas rêver. L'hydrogène à 2 $ le kilogramme, c'est pas ni aujourd'hui ni demain. D'accord? Donc, quelque part, il va falloir que quelqu'un paye pour avoir une énergie décarbonée. Et donc, la réglementation, à mon avis, européenne doit aller dans ce sens-là. Et bien entendu, comme l'a dit Madame la Ministre ce matin, aujourd'hui, il faut qu'on arrête les effets d'annonce. Il faut peut-être qu'on rentre dans des projets, je dirais, à taille, entre guillemets, humaine, n'est-ce pas, pour enclencher le processus et commencer à produire l'hydrogène et les produits dérivés. L'hydrogène pose d'autres problèmes de logistique, de transport, n'est-ce pas, ce qui fait qu'on est obligé d'aller vers des produits comme l'ammoniac ou le e-méthanol, des choses comme ça. Donc, je pense que pour le Maroc, c'est une opportunité, n'est-ce pas, de devenir à terme un pays exportateur d'énergie, honnêtement. Pour le continent européen qui est notre voisin, c'est aussi une possibilité d'avoir un fournisseur à côté. Je pense qu'on peut avoir une énergie compétitive, je pense qu'on peut produire, fournir le marché de manière compétitive, mais tout ça, ça suppose un partenariat plus profond, à mon avis, entre le Maroc et... Bon, il y a les opérateurs privés, c'est clair. C'est à nous d'investir, c'est à nous de développer les projets, mais on a besoin d'un cadre qui soit encourageant, clair, des deux côtés, aussi bien du côté de la production que du côté des off-takers. Voilà, à mon avis, ce qui peut accélérer le développement du renouvelable au Maroc.
Thank you. Thank you, Senaposh, for this insight. So, sorry for who are not speaking French, you can use the headset for translation. Sorry. So there is headset available for who are not speaking French. Coming to our topic, so we talked about competitiveness, how we can accelerate this energy transition. Key point is research and innovation. So how research and innovation can enhance supply chain logistics for a global green H2 integration? How digital and AI can support the green industrial growth? And I let Ahmed sharing with us his insight about this question and about these topics. Thank you.
Thank you very much. Good afternoon to everyone. Actually, to address, the green industrial growth, I would like to come back a little bit into the history. Through human history, it was shown that each round of the industrial growth, it was associated with a kind of energy growth. This started from the age of agricultural civilization, where bioenergy like timber was the main energy source in the past, and this pushed somehow and promoted, the revolution toward an agricultural economy. Later on, in the age of the industrial, economy, fossil fuels like oil, like natural gas, was the main energy source and pushed somehow the transition from the agricultural economy and agricultural civilization toward an industrial civilization. Now, I think that there is another key parameters coming to the game, which is the information revolution. I think what we witnessed through the 50 past years on the information revolution, with the deployment of laptop internet, with the deployment of the mobile phone internet, with the deployment of the industrial internet, and now with the 4G, all the IoT deployment worldwide, with the artificial intelligence, data centers deployment, and all the cloud computing. I think now with what we are seeing now on the green energy revolution, if we add this to the information revolution, these two elements are preparing us for the next, we call it the fifth coming industrial revolution. And I think that this revolution will be a green revolution. Why I'm saying sure? Because all we know that carbon neutrality is not anymore a kind of slogan. It's becoming a reality. And especially when we see that now more, all the sovereign countries are part of the UNFCCC, the United Nations Framework Convention on the Climate Change. We also see, more than 195 countries, adopted the Paris Agreement. When we see last year, July, more than 150 countries, they set up their own strategy toward carbon neutrality. So for sure, this is a huge step ahead to go toward this green industrial growth. We think also that digitalization will play a crucial role, sorry about this topic, and so on. So to go ahead, there is, of course, this policy driven reason toward carbon neutrality. And I think that there is additional two reasons. The second one is somehow a business-driven reason. We can even call it a commercial reason. So when we see the costs produced from, the cost of energy produced from renewables, especially wind and solar, now we are witnessing a kind of competitive LCOE and LCOS, levelized cost of electricity and levelized cost of storage. And this, for sure, will prepare the floor for to get a competitive LCOH, and especially a green levelized cost of hydrogen. And when we talk about industry growth, it's somehow related to an energy growth, somehow related also to economic growth. So when we see now that an investment of ICT technologies of about 20% can generate up to 1% increase on the GDP. When we see, that now ICT investments are 6 to 7 times are much more profitable than the other businesses. So we think that now the LCOE will continue to drop on the coming 4 years, by 50% on the LCOE from solar, and by about 70% drop on the LCOS of battery energy storage. So this for sure will push the floor and prepare the floor toward carbon neutrality, and especially now the expectations are saying that by 2030 we will have almost 1/3 of the installed capacity coming from solar, that the installed capacity of storage, battery energy storage, will move from 39 gigawatt hour to almost 500 gigawatt hour by 2030. So it's, once again, it's a reality, and we have to take benefit of it to push furthermore the deployment of green hydrogen, because you know hydrogen now is not, it's becoming a catalyst also toward the energy transition. So what I want to add as a point is that to go ahead on this topic, I think we have to give high attention to innovation. And by the way, sorry, this is what we are doing within Huawei. So, you know, we are investing around 20 to 25% of our annual revenues into the R&D. So basically, we are applying a basic concept. We are working what we call the 4T, the byte, the watt, the thermal energy management, and also the battery energy management. We try to apply this concept on all the applications. So, you know, from energy production, green energy production, to the transport, to the distribution, and behind all the infrastructure behind. So when I say infrastructure, this concerns, you know, EV charging deployment and EV cars deployment also, and all the 5G and IoTs and in clouds and data centers in smart grids and so on, because we think that this is one of the key parameters toward the green world. Last but not least, I want to address one key point. It's about, you know, the infrastructure adoption. Is on, you know, I heard that indeed, you know, the electricity grid need to be developed. Of course, investment should be done in this sense to have the capacity to absorb more renewables and so on from wind and solar with batteries, with HVDC lines and so on. But I think now much more focus is done on the technology. On the market now, we have technologies like batteries with grid forming and black stars, combined with wind or solar, which are capable of providing, you know, a reliable and a stable energy source. So indeed, it should be working in parallel, developing the grid, but also looking to technologies capable even of replacing the traditional, conventional technologies, you know, like synchronous machines and so on, especially that grid-forming batteries with black start now can enable the deployment of 100% of renewables on a grid, or even in a microgrid or mini-grid, and even off-grid scenario. Thank you.
Thank you, Ahmed, for this interesting presentation. So now I think we are close to the end of this session. So I will ask you one question to close this session. What is, according to you, the priority, one priority, the most important one for the coming months or for this year? Because this World Power 2 Weeks Summit is once a year. So that will be our priority, according to you, for this year. So we will start with you, Khalid.
It's a good question. Difficult to answer because we need to accelerate. And from my point of view, I think here, as we said, you talk about maturity. We fully agree that there is a need of more testing, more understanding how electrolyzer works and how electrolyzer behaves when there is intermittency. Because today, the main question when we have to go to the business plan, what is the life duration of this business plan? How many times you have to change the electrolyzers or the components? For me, the key question, need testing, understanding, and sharing, and connecting academic with industrial.
Thank you, Khalid. Same question to you, Omar.
Thank you for the question. It's a very important question. I think in the world there are two mega trends. First is sustainability. Second one is AI and data. So data will need more energy and more green energy. Today, the total use of AI is around 1% of the total energy in the world, which is around 200 terawatt-hour. And in the future, not the near future, 2030, it would be like 1,200 terawatt-hour of energy that we need. So if Morocco can capture part of this market, we're talking of different paradigm. So we need to invest today, for sure, on the short term, on the network, on flexible capacity to being integrated on the grid. For me, this two short-term priorities. But in the midterm, we need to look big and be attractive for investment in data and AI in the future.
Thank you. Sinakosh?
Yes. For me, if I have to choose one priority, I think it's clear and final regulation framework from the off-take countries.
Merci. And last but not least, Ahmed.
Yeah. Yeah. So actually, from my side, I have one amendment. Somehow, it's related to the technology maturity. I think, from my point of view, that the technology is going too fast, and even the world going too fast. So, from my point of view, if we still all the time to wait the maturity of the technology, we will never go ahead. I think in the world we have experiences that we can learn from. You know, in Australia about the grid challenges because they have a weak grid, and many countries actually they are quite ahead on the renewable energy deployments and even green hydrogen deployments. So we can learn and we can go ahead on this topic and use the available technology and so on. So my point is somehow related to what Mr. Nakour said. It's I think in the short term, in the coming months, I think a clear framework should be prepared, so to be clear for all the investors in the industrials to take the courage to step ahead and invest and deploy, you know, the different projects and so on. Thank you.
Thank you very much, Ahmed. A big applause for our panelists. Thank you very much. Thank you, and I propose you to have a photo together before letting the floor for next session. Thank you.